So today we're going to talk about fault finding. So today's lesson is on fault finding, where we've discussed about wiring. We've discussed in previous lessons about different types of terminations, different types of cables. We've gone through design. So now we're looking at actual fault types. So this will be where we've done something or someone else has done something and it has been up and running and working, or something is about to be set up and working and doesn't work. So a lot of times it will be a fault on a installation that's been up and running for years or a while, or it could be on a brand new installation and you've done some testing and you found that you've got some funny reading results. Now, the main thing that we need to look at before I get into the PowerPoint presentation is that we stick to all the things that we've learned. So we need all the safe working procedures that we've got. They need to be stuck. You know, we really need to stick with the safe working, and also we need to work in the electricity at work regulations. So we need to stick. So all of the things that we're doing here, we need to stick within those guidelines and those things. So let's look at the faults. So one of the first types of faults that you might get is a loss of supply. Now, you may be called to deal with a fault where equipment has apparently failed, but do not overlook the supply itself. Could be interrupted. It's always good to check the supply is present. This may be obvious. Other electrical equipment is functioning. However, in a three-phase system, it's also possible to lose one phase of supply. And we looked at that when we were looking at phase rotation and phases. But the loss of supply, I used to get called out sometimes and we'd do things, and it could be the simple thing that either there's a power cut, which that would be quite obvious because the whole of the building has gone down. It could be that a fuse has gone in a plug top. Sometimes, you know, a plug top could have been plugged in for 10, 12 years and that fuse may have just failed. And it could be as simple as that. That might not even be a fault. So before you start going into really extravagant, looking into great details, always check you've got a supply. It is sometimes the easiest to look for, and sometimes it's the easiest to rectify. So always look for loss of supply. Now, low voltage or volt drop. So this may cause equipment not to function properly and in some cases fail altogether. Loss of voltage can be a symptom of high resistant joints or heavy load on the system with heavy currents causing excess volt drop. So the low voltage or volt drop may be the cause of another fault along the way. So we can look at those in a second. Component, equipment failure, malfunction. Due to many possibilities, the actual equipment itself may fail, or an individual component within a piece of equipment. This could be caused by misuse or the component, or simple it wearing out. I had a phone call from a friend of mine the other day because their dishwasher was tripping, and you know, but the dishwasher's 13 years old, and from the symptoms it could be the motor or it could be the heating element that's gone, and that would just be that there's no misuse there. It's just over a period of time. A lot of the time when I used to deal with immersion heaters, that the heating element would go in, you know, and that would cause a problem. Overload. So operation of overload or fault current devices. If too many pieces of equipment are connected to an otherwise healthy circuit, this may cause the device to operate. And we've looked at this, and I've got those silly diagrams of where we've got sockets plugged on top of sockets, plugged on top of sockets. And basically where you've got a circuit, because we've done the design, and the circuit might be rated at 32 amps, it might be rated at 20 amps, and too many things are plugged in, and it's drawing too much current. But the circuit itself is healthy. So that is quite an easy one. Now, arcing, loss of connection. If a connection becomes loose, it may break the circuit completely, causing a complete failure. The connection, however, may not break completely, but produce an arcing. This may result in excessive fault drop, but more seriously may cause a fire. Now with arcing, if there is still power, you can sometimes hear that arcing, that little crackling sound, sometimes in a light switch, sometimes in a socket, where either the screw has become loose or something's happened, and it's just that arc. So the connection hasn't completely broken. There's like a minuscule gap, and you create an arc. Now that arc can cause a fire. High resistance, loose connection. As mentioned previously, a loose connection can cause high resistance that can cause serious fault drop and excessive heat. Transient voltages is a lightning strike. If a premises receives lightning strike, then severe damage can be sustained by the installation and its components. Even the wiring itself could be burnt out and would need completely replacing. I have seen some lightning strikes, and the actual cable where it's been struck has evaporated. There is no cable left. All that was left was some insulation, and there was no cable left. It literally has vaporized it. Excessive current overload, possibly caused by a consumer connecting too much equipment again to the circuit, or a machine being subjected to excessive mechanical loading, resulting in an overcurrent occurring. So if you've got a motor going, but the motor's not spinning because something's causing too much pressure on it, whatever, that could create it. Insulation failure, deterioration. If the installation starts to deteriorate, current can leak either to adjoining conductors or to earth. This can produce a localized heating at the point of breakdown and eventually a serious overcurrent. When I first started working, there was a common cable that had been used beforehand, which was called vulcanized Indian rubber. And that literally was the insulation, instead of being plastic, was rubber with a little, like a cloth around the cable. And you would tap that cable and it would just disintegrate. The rubber would just crumble away, leaving live conductors or bare conductors. Mechanical damage. The installation may be damaged by mechanical means. For example, a forklift truck striking a wire enclosure. Somebody, could accidentally damage a cable, put a nail through a wall or whatever. It could be mechanical damage. So how these materialate, and then we'll look at this when we actually do fault finding and we do fault diagnostics. But faults can generally be classified in two ways: open circuit and short circuit. A short circuit is where there is a direct contact of negligible resistance between live conductors. So line to line, line to neutral, and line to earth, which will cause high fault currents to flow. When the latter occurs, it's called an earth fault. So if there was a fault between line to line or line to neutral, it's a short circuit. Or if we have a line to earth, we call that an earth fault. With an open circuit, the circuit is completely broken in some way and no current will flow. So the equipment supply will not work. So it will seem like there is no supply getting to it. Now, signal faults. Many production line machines are controlled by PLCs, programmable logic controllers, which are basically beefed up computers that receive inputs from controllers and sensors and then operate various pieces of equipment on the production line. If there is an issue with the software, then either a wrong signal or no signal can be sent to individual pieces of equipment. And also sometimes sensors can go faulty. So if you've got a sensor that says the door is open, but that sensor's broken or damaged, it may not see that, or a motor may speed up. There could be speed control. So you have signal faults. Any of these faults can occur in various locations within the wiring system, including the following: the wiring itself, termination and connections, equipment and accessories such as switches, luminaires, switchgear and control equipment, and instrumentation and metering. So we're going to look at any questions in a second, and we're going to go through the worksheet now.